Okay, fractions, 1/6 plus 3/4. Okay, now when you add fractions, the denominator needs to become the same. At the moment, they're different. You've got 6 here and you've got 4 here. They're both different, so we need to change them so they're the same. So you need to think of a common multiple. Okay, for 6 and 4, the number that 6 and 4 goes into. Okay, now I'm thinking 12. Okay, you might be thinking a different number. You might have had 24. They both go into 24, and that's right. But they also go into 12, and if you can find the lowest number, that's even better. So to change that to 12, you're timesing it by 2. So you've got to times the top by 2, end up having 2/12. Same then here, 3/4, let's change this to 12. 4 goes into 12, of course, isn't it? 3 times. So you times the top by 3, and you get 9. So we're actually adding 2/12 and 9/12, which is 11/12. Okay. Alright, now if you had an answer which is different, maybe you put it out of a different denominator, you could still get to this by simplifying. For question 2, you've got mixed numbers to add here, right? So when you do mixed numbers, it's actually really simple. What you do to start with is you add the whole numbers. So you've got 6 and 10 is 16. Okay, so sort that out first, and then focus on the fractions. Let's work out what 2/3 plus 1/4 is. Again, you need to change the denominators. So number 3 and 4 go into, and again 12 will work, won't it? So here you times them by 4, so you times the top by 4 and you get 8. And then you've got 1/4, so you times that by 3 in that case, isn't it? You get 3 here. If you add them together, 8/12 plus 3/12, okay, that's what it becomes. You get 11/12. So in total now, you can put them together, then you've got your whole numbers, which is 16, and then your fraction is 11/12. Question 3, write 47 as a mixed number. So in this case now, you need to know your 7 times table, and you need to see how many times 7 fits into 40. So if you go through your 5 times table, you know 5 times 7 is 35. 6 times 7 is 42. Now that's too much, okay? So it can't be 6, okay? It's got to be 5. So it goes into it 5 times. That makes 35, so think what's left over now. 35 to 40, there's 5 left over, 7. So there's your answer there. Question 4, write this as an improper fraction. Now we're talking about thirds here, okay? How many thirds? We've got 2/3 here, haven't we? And of course, in 2 wholes, there's a certain amount of thirds. If you think about it, in 1 whole, okay, in 1 whole, there's 3/3, yeah? In 2 wholes, there's going to be 6/3, okay? 3/3 here, 3/3 here, so that's 6/3, plus the other 2/3, you end up having 8/3, okay, with the extra 2/3 at the end. Quicker way of doing it maybe is just because we know there's thirds and you've got 2 wholes, so you know there's 3 wholes. There's 3/3 in a whole, isn't there? There's 3/3 in a whole. So in 2 wholes there'll be 2 lots of 3/3. So you're actually timesing these together, right? That's what's going on. So you do 2 times 3, which is 6. Add that, and you get 8/3. That's your answer. Okay. Question 5. How many quarters are there in 2 and 3/4? Well, again, you need to think how many quarters are there in 2. Okay. Well, in 1, let's start off with. Quarters means divide into 4 pieces. So in 1 whole, there's 4 quarters. Yeah. In 2 wholes, there'll be 8 quarters. Yeah. Okay. Because 8 quarters there, plus then the other 3, that's 11 quarters. Okay, now it's asking for how many, right? It's not asking for fractions, it's asking for how many, so you need to say there are 11 quarters. Okay, write the fraction that is exactly halfway between 1/10 and 3/5. Okay, now in this case, you need to, again, we compare in fractions, we need to find the common denominator here. Okay, so we need to change this. I mean, you've got 1/10, all right, 3/5. We could change that, couldn't we? So that's out of 10, so that would become 6/10. Yeah, I just double the bottom, so I double the top. So we could now see what goes in between these two here. Okay, what's exactly in between these two? Now, if you think about it, between 1 and 6, the gap there, the difference is 5, isn't it? Okay, so if you go halfway between, that gap will be halved. So we want to go 2.5, don't we? From 1, we want to go to 2 and an extra 2.5. So if we add 2.5 onto 1, we get 3.5 out of 10. Okay. Now you can't leave your fraction with a decimal in it. So of course, what we can do is be clever. We could actually double the top, couldn't we? So we get 7. You've got to double the bottom. So you get 7/20. So that's halfway in between. Question 7, 3/8 of 40. Well, what I would do is work out 1/8 of 40. Okay, 1/8 of 40 to start with. And that just means 40 divided by 8. That's what 1/8 means. Just 40 divided by 8. And 8 goes into 40 5 times. 3/8 then, well, 1/8 is 5, so 3/8 of 40 will be 15. Okay. Question 8 then, 1/4 times 1/4. Well, when you multiply in fractions, it's even easier than adding. Multiplying fractions is simple because you just times the tops. You get 1 times 1 is 1. And then you times the bottoms. 4 times 4 is 16. So that's the answer. Here, again, you're going to be multiplying because when we're squaring here, basically it's saying times by itself. This is 3/4 times 3/4. When you times these here, times the tops, you get 9. Times the bottoms, you get 16. Okay. Last question on fractions. It says, what fraction here is shaded? Now this looks quite complicated shape here, but what you need to realize is that we can actually figure out what fraction is shaded if we get the same fraction size. Okay. Now here we've got different shapes, haven't we? Got a large square here, a rectangle here, a narrow rectangle here, small squares here. Look for the smallest shape. It's a square here. And we could actually divide this up so that we've just got all squares. Let me show you what I mean. We've got this line here. If we follow that, okay, down like that, and I could do the same here with this line. Okay, I can continue this line down here. Okay, we want to get the same shape throughout the whole thing. This line here, I could keep it going down there. Now maybe I could go across here, across there, across there, down here, okay? And I think this is the last one, is it? Now you can see this is much more manageable, okay? And then we can count how many squares there are in total. And I think it goes 8 across and 8 down, so 64 squares, okay? Let's count them when you're shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is 18 shaded. This is 18 of the 64. We can simplify that. We could halve it, couldn't we? Halve the top, halve the bottom, and we're done.